How's it going? This is Mr. Newbold trying my new video camera, see if it works. So this is for the inequalities assignment, absolute value inequalities. Don't forget your name. Kermit the Frog here. Okay, so we're going to take a look at maybe number, just to make it easy, we'll start with number 2, just make sure you kind of know what's going on there. So basically you drop the absolute value symbol and you just do x is less than or equal to 2. And so then we're trying to find two solutions, so that's going to give us one of them. And then you have to change the inequality sign. So you're going from, this is for the second equation. So then, because you're going to break it off into two equations. And so one with the less than equal to, the other one with the greater than equal to, so just switching the inequality signs. And then also changing the sign of the number itself. So we're changing stuff here as well as here. Switcheroozy. Right? Switcheroozy. Okay, so then, excellent. Now we've got it all solved there. So we want a graph. So this is a less than, right? This symbol right here is less than. So we'll call it less than because it's and. And so and means that you're going to be sharing everything in between. Also, don't forget that sharing everything in between. Also, don't forget, you can write this down, that less than, greater than is an open hole, open. So less than or greater than is an open hole, right? And then less than equal to, greater than equal to is a closed hole. So don't forget that, don't forget that. Awesome. So back to our problem number 2. So we have x, all numbers x, greater than or equal to -2. So we're going to go to -2 on our number line like this. And because it's less than or equal to, we're going to go ahead and put a closed dot. Closed dot, there we go. And then x is less than, so that's, let's see, so that's greater than or equal to -2. So what's greater than -2? Well, 1, 2, 3. So we're going to go in this direction. Then x is less than or equal to 2. So then we're going to go to 2, do a closed dot again, but we want to do less than 2, so that'll go this way. So we end up doing everything in between, which is a less than problem, less than. Excellent. That's less than. Cool. So then we'll do another one on this assignment, like maybe, for example, number 11 would be a good one. So number 11, hope I'm not talking too loud my first time doing this. So number 11, we actually have to do some division first, because you have to isolate the absolute value. You want to get everything with the absolute value. So isolate the absolute value stuff and get everything else on the other side. Everything else on the other side. Good. Okay, so we're going to bring this down. We're going to do 7 absolute value of x over 8. And then less than or equal to 7. And so the first step there, oops, there it is. So the first step there is we're going to go ahead and divide. We got to get that 7 to the other side. When it's just next to it, that means multiply. So we're going to go ahead and divide by 7, divide by 7. So that's going to get it to the other side. So then we're left with x over 8 is less than or equal to 7 divided by 7 is 1. Excellent. Okay, so now we're going to split this off into two separate equations. And we're going to drop the absolute value. We're going to do x over 8 is less than or equal to 1. And then we're also going to do x over 8 is greater than or equal to -1, right? Changing the sign as well as the inequality sign as well as the number sign. Okay, so then we're just going to solve for x by timesing 8 over to the other side. So then our final answer there is x less than or equal to 8, because 8 times 1 is just 8. And then over here we're going to go ahead and times 8 to the other side as well. And so then we get x is greater than equal to -8. Greater than equal to -8. Awesome. We should check it and plug it back in, make sure it works. So it says equal to 8, so 8 and -8 should work. Yep, because 8, plug it in. So if you plug in 8 right here, whoopsie. If you plug in 8 right here, 8 divided by 8 is 1, and that's times 7 is 7. Yep. So equal to does work, but what about the other symbols? Let's take a look at that in a second. Okay, so now we're going to go ahead and graph that. So we're going to go ahead and go to 8, and we're going to go and do less than or equal to 8. So this is a less than, so this should be pointed inwards again. So we have 8, excellent. And then we have -8, which is over here, excellent. And so now we want all numbers less than 8, but greater than -8. Less than 8, but greater than -8. So that means that we're going to go ahead and do everything in between. And now we could make sure this works by plugging in a random number from these solutions. So the infinite solutions, because it could be 0.1, 0.2 would work, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, 1, 1.2, 1.3, all the way up to 2. So we're going to try just plugging in a 0. So 0 divided by 8 is 0, 0 times 7 is 0, and 0 is less than or equal to 7. So it works. Nice. You could try maybe another number, like maybe 4, plug in a 4 there. So 4 divided by 8 is a half, and half of 7 is less than 7. Cool, so all those work. So this definitely works, and there's our number line solution. Okay, so next we're going to flip over to the other side. Actually, I think it's number 12, I believe, where it got a little bit tricky there. So number 12, we'll put a star next to 12. And so what I'm going to say for number 12 is you want to make sure that when you divide with inequality, so when you divide by a negative number, right, when you divide by a negative number, then make sure to switch the inequality sign. Switch the inequality sign. So I'm going to let you come back and try 12 on your own, because I want to do a problem on the back side. So we'll do 17 or 18. Which one should we do? Which one should we do? 18, you like 18? Let's vote on it. Vote on it. 1, 2, 3. Vote on it. 4, 5, 6. Oh, 18. 1. Okay, so here's number 18. So with number 18 now, we do have to isolate the absolute value first. So we are going to minus 5 to both sides, and 8 minus 5 is 3. So we're going to end up with 6 minus 3n absolute value, minus 5, minus 5. So 8 minus 5 is greater than or equal to 3. So don't forget that symbol means greater. Emphasis on the or, greater. And so that means that this is going to be going, solid dots, hopefully in opposite directions, right? Opposite directions, that's what we need. So let's go ahead and try it now. So we minus 5 to the other side and isolated the absolute value. Now we're going to go ahead and drop the absolute value and do two separate equations. So kind of like the absolute value, regular absolute value. So 6 minus 3n is greater than or equal to 3. And then we also have 6 minus 3n is less than or equal to negative 3. Remember that? Separated into two separate things going on there. Okay, beautiful. So then, let's see here. So we're going to go ahead and solve for these now. So we're going to minus 6 to both sides like that. So we get negative 3n is greater than or equal to 3 minus 6 is just a negative 3. And then we're going to divide by negative 3, divide by negative 3, okay? So then, if you did it wrong, which I'm about to show you, so n greater than or equal to negative 3 divided by negative 3 is a positive 1. So you're actually going to have to switch that inequality symbol. Let me show you in a second why. Just a second. Let's do the other side now. So we're going to go ahead and minus 6, minus 6. So this time we get negative 3n is less than or equal to negative 9. Negative 9 there. And so then we're going to divide by negative 3, which you should switch the inequality symbol, but let's not do it for a second. So n is less than or equal to 9 divided by 3. Negative is a positive 3. Okay, so you should switch this, right? Switch it. And the reason why you want to switch it is because if we didn't, you would do all values 3 and less, which would be here, right? All values would be 3 and less pointed inwards, and then all greater than 1. So that'd be greater than 1, which would be 1, 2, 3. So all of a sudden you're doing between those two, but this is a great or problem, and great or problem means go to the left or the right. Okay, and so we need to switch it, so now it's n is less than equal to 1. Okay, so now we're going to do n is less than equal to 1. We're going to switch that symbol, and then we're also going to switch this one, so n is greater than equal to 3. Good. So now we're going to go in opposite directions, which a gray Tor problem would do that. Let me show you what I mean. So now we're going to go back here, and so instead of going that direction, we're going to go 3, and we're going to go greater. Okay, greater should be right. And then 1, and then it says less than or equal to 1, so less than 1 would be 0, -1, -2. So -1 going to the left now, going to the left. Excellent. So let's show you why. Let's show you why we had to switch those. So let's say that you thought the solution was 2 and that you went in between them. So if you thought it was 2, well, let's see. Let's plug it in. So we're going to go ahead and we're going to plug that in just to show it to you. So the original problem again then would be 6 minus 3 times whatever we plug in, which we're going to go ahead and plug in a 2. It's supposed to be, according to the original problem, plus 5 greater than or equal to 8. Okay? So 3 times 2 is 6, so we plug in a 6 there, or 2 times 3 is 6. 6 minus 6 is going to be 0, plus 5 is greater than or equal to 8. Okay, so then the 0 goes away. We're just left with 5 greater than 8. And that is not true. So not true. So that's why we don't go between 1 and 3, right? Because 2 is not a solution. No, not a solution. But going 4 to the right and 1 to the left are solutions. So I'll give you another example where it is a solution. So maybe we could do like 4, for example, to see if that is a solution. So we go back to our original, and we plug in a 4 instead of a 2. So we have 6 minus 3 times 4, absolute value, plus 5 greater than or equal to 8. And so there it is. We plugged in a 4 right there. 6 minus 3 times 4, close absolute value, plus 5 greater than or equal to 8. So then 3 times 4 is 12, and 6 minus 12 is a -6, plus 5 greater than or equal to 8. And there it is. So 6 minus 12 is a -6. The absolute value, -6, is +6. And 6 plus 5 is 11. And 11 is greater than or equal to 8. So that works. That's a true statement. So 4 works, -4 works, just not between 1 and 3. So there we go. There's our answer solution going to the right and to the left. Awesome. Thanks for watching this video. There's my thumb. What up, what up? Yeah. Woo! Thanks for watching this video. See you next time.